Hello everyone. Today we're going to talk about characterizing data. So we're going to first talk about finding the measures of center. And this is just a numerical way of determining where the centermost point is in our data set. And in this section, we're going to talk about three different ways of finding the center of the data set. We have the mean, median, and mode. And some of you probably have heard of each of these, so I'll just briefly go through them. The mean, simply you just add up all the values in your data set and you divide it by the total number of values. The median, you just look for the middle most value in your data set. And the mode, you just look at the value or values that occurs the most in your data set. Now, sometimes we can have outliers in your data set, and these are values that are either really big or really small compared to the rest of the data set. And outliers definitely affect how our values are calculated. So the mean, for example, is greatly affected by outliers, whereas the median ends up not being as affected. So the median and mode actually become unbiased estimators, whereas the mean is biased, meaning that it is biased towards any extreme values. So we would ideally like to remove outliers if we can, but oftentimes we have to justify whether or not we can remove them. And sometimes they are part of the data set, and sometimes they are recording errors. So looking at these 9 exam scores, we're going to go ahead and calculate the mean and median. So for the mean, we're going to go ahead and take 100 plus 76 plus 25 plus 86 plus 92 plus 84 plus 84 plus 88 plus 62. We're going to divide all of those by 9 since there are 9 exam scores. And when we do that, we end up with 77.44 repeating. Now for the median, it may help to rewrite these. So I'm going to rewrite these from smallest to largest. And to find the median, basically I'm just going to cross off each number one at a time. So I crossed off 4 on the left and 4 on the right, and it turns out that I am left with 84. So this is the mean, the median equals 84. Now, noticing from that example, we had 25 was a really small number, so potentially that could be an outlier. So what happens if we were to calculate the mean and the median without using 25 as the exam score? So I'm going to go ahead and add up all 8 numbers. Now we're going to only divide it by 8 since we only have 8 data points. And we end up with the mean of 84. The median, on the other hand, is a little bit trickier because now we have an even number of data points. And if I start crossing those off, so 1, then 2 on both sides, 3, now notice that I'm left with 2 numbers in the middle. What I do with these is I actually average these two together. So I take 84 plus 86, divide that by 2, and I end up with 85. So now I have a median of 85. So should we, in fact, ignore 25 when calculating the mean and median? It is possible to have an exam score of 25, so it's not something that we can necessarily remove without maybe going back through and seeing where that exam score 25 came from. Maybe someone just decided to guess on all the questions and didn't study for the test, or it could be a simple recording error and maybe they actually meant to write down 75 instead of 25 or even 52. So long story short, we cannot remove this without at least investigating where it came from. Now let's look at finding the mode for the following sample data. Now the first case, we only have these 2 numbers that show up more than once. So the mode in that case is 84. In the next case, we have 0 and 5 that show up more than once, and they're the ones that show up the most number of times. 1 does show up twice, but not enough. So the mode is 0 and also 5. For the last one, none of the numbers show up more than once, so we would actually say that there is in fact no mode. In the last video, we briefly talked about histograms and line graphs. And what they did was they showed us mostly where our data set lies compared to the other data points. And we can describe the shape as the distribution. So diving into more about how the shapes of distributions work, we have different ways of characterizing them. So we have unimodal and bimodal. Unimodal distributions have one mode, so they basically just have one peak. Bimodal basically means that it would have two different peaks. So maybe you have something like looks like this, for example. That would be a bimodal distribution. And to characterize unimodal distributions even further, we can characterize them by how they are skewed. So either they are left skewed meaning that they have a long left tail, right skewed meaning it has a longer right tail, or it could be symmetric. And notice that in each of these, the mean, median, mode lie in different places. Mode lying right at the peak of the curve. The median is the next closest to the mode, and then the mean is the one furthest away from the mode. And also notice that if it is perfectly symmetric, the mean, median, mode are all the same value. So in this example, we can make a sketch for the distribution that we would expect to have from the following. The first one has exam scores for 100 students when 4 students got an A, 25 students got a B, 20 students got a C, and I think those are the only scores we have to work with. Now, this one's probably not very clear as to how we would arrange this. You could actually rearrange this in one of two ways. You could have the highest scores first and then go down, or we could have the lowest scores first and then go up. I'm going to go ahead and set this up so we have the C's first. So this will represent C, then B, then A. So we have 20 students that got a C. We have 25 that got a B, and then we have 40 that has an A. Now, kind of just getting a rough idea on what this distribution shape looks like. You can definitely see that this has a longer left tail, so this is unimodal and left skewed. In the next one, we have the weights of all people who use an ice rink that is open to figure skaters in the morning and hockey players in the afternoon. Now, we're looking at weights, and I noticed that we have two different types of people that are using this. We have figure skaters, who are in general lighter, and then hockey players, which are generally heavier. So this tells me that we're going to basically have two different curves. So we can basically say that these are your ice skaters, and then we have our hockey players. And so again, keep in mind that this is a number line on the bottom here. So if we were to start off at like 0, like probably clear over here actually. So if this is 0 for the weights, this may be like in the 90s or 100, low hundreds. Actually, it's probably a little bit higher than that, but you get my point. Then we have hockey players, which will probably have an average weight of maybe 180 or 200 or something like that. So that's how we have our two different distributions. Now, look at the last one. We have the numbers of people whose street address ends in 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we're going to have to assume that all of these have the same chance of being selected. And so what this will actually look like is that the heights will actually be the same no matter what the number is. If it's 0, if it's 1, if it's 5, whatever it is, all of them are going to have the same chance of being selected, so the heights will all be the same. And this actually has a special name called the uniform distribution. So average gets used quite a bit, and in fact I actually used it earlier in this video. And what's confusing about the average is it has different meanings depending on the context of what you're looking at. And average can actually represent either the mean, median, mode, or other measures of center not talked about in this section. So what we're going to do is we're going to determine if the mean, median, or the mode is going to be the best measurement for the following averages. Now, the way to determine this is we need to look and see, is this unimodel or bimodal or multimodal, that's for 3 or more modes. Or we also need to look at, do we have any outliers? If we have outliers, then we want to use the median. Otherwise, if we do not have outliers, or if it's more symmetric, we want to use the mean. So the average household income in Missouri. Now, if you want to know what the distribution of household income looks like, maybe you would expect the average to be, let's say 40,000, right? Just kind of making up a number here. So if we have 40,000, we would expect some people to be uh, fairly rich, right? Like you might have someone that has an annual income of 100,000 or even a million might be a little extreme, but you get my point. So let's say that we have 40,000 here, and then we have like all these rich people kind of towards the top here. So this looks to me as if it is actually skewed to the right. And because of its number being skewed here, it would actually make sense to use the median. Because the median is going to be closer to where we would say the average of our data set is compared to the mean, which will probably be closer to the right tail. And we only use the mode if there is more than one mode in the data set. Number 2, the average age at first marriage for men in America. Now, with this, I would guess that the average would be, let's say, 22, right? Might be a little bit higher, might be a little bit lower, but it's about 22. And it is possible for people to get married in their 60s or 70s or even older. However, you can't really go a whole lot lower than um, 20. So again, this is one of the cases where, oops. So again, this will end up being a right skewed distribution. And I would again use the median as the average. For number 3, the average weight of potatoes in a 10-pound bag, I believe we can say that this will actually be a symmetric curve. So I think it would make sense to say that we want to use the mean. Another way we can look at the distribution is looking at its variation. So how much spread is there in the data set? So we can have low variation, moderate variation, or high variation. So if we're to look at the last 3 examples, I would say that maybe if this is like 80, for example, and this is 100,000, I would say the spread of the Missouri example would be much higher than the spread in the marriage example. And of course, both of those are going to have a larger spread than the average weight of potatoes in a 10-pound bag. So I'm assuming that we're measuring these in pounds. Those are going to be closer to like maybe half a pound, for example. So those numbers are a lot smaller, so the spread will be relative to the numbers we're working with. Thank you for watching, and I'll see you in the next video.